Open almost any modern digital tool, and you are greeted by a blinking vertical cursor against a blank white background. Because this layout matches the messaging apps we use to talk to our friends, it shapes how we interact with the system. We instinctively type into these boxes, expecting a casual back and forth, treating a high-dimensional engine like a simple digital assistant. We adopted the term Chatbot to describe these tools, a label that suggests a simple, rule-based script returning pre-written answers. It frames the technology as a novelty for conversation, rather than a tool for computation. We ask for a quick dinner recipe, request a polite email draft, or grab a fast summary of a long PDF, expecting a single static response. In reality, each message acts as a set of constraints. When you press enter, you are submitting instructions that the system must interpret and execute. By staying within the mindset of a chat, we often overlook the underlying architecture, leaving the system's broader capabilities largely untouched. A standard two-dimensional chat bubble pivots, revealing the architecture behind it. This interface acts as a glass pane, separating you from a massive back-end network. It's an abstraction layer hiding the billions of parameters responsible for processing your input. This system does not possess the human capacity for conversation. It is a synthesis engine. Every submission triggers a cascade of computational tasks. The engine performs probabilistic reasoning and carefully synthesizes data from its vast training weights to generate structured outputs. There is an asymmetry to this interaction. A human provides a dozen words of input, which the system uses to execute a high-volume computational run. The value of the technology lies in this back-end execution, the ability to turn a simple text string into a logic-driven result. To understand how to control that execution, we have to look at the anatomy of a single message. A natural language prompt serves the same purpose as a line of code. You are passing variables and instructions to a model that compiles those English words into a specific action. Comparing input quality, a vague instruction yields scattered results, while a structured command produces a dense, organized data matrix. Because the system remembers context, the matrix expands, simulating multiple potential outcomes, pruning paths that fail until reaching the optimal path. When you correct the system or add a new constraint to a previous answer, you are essentially debugging the output until the logic holds. Reframing a chat thread as a workflow changes your role. You're no longer just asking questions, but directing a system toward a specific goal. Historically, using a computer required navigating rigid, predetermined paths. Software was built with specific, closed boundaries. Traditional interfaces forced users to translate their goals into machine actions using these restrictive elements: menus, sliders, and fixed toggle switches. Natural language models replace that rigidity with an open-ended interface. In this new operational flow, human intent maps directly to an expression, which generates a result without intervening menus or fixed paths. This creates a universal way to interact with artificial intelligence, regardless of the specific task. Through one text bar, you can analyze complex data, plan a business strategy, write software, or generate creative works, all using the same input method. For the user, the primary barrier to solving a problem is no longer technical literacy, but the ability to clearly define the problem itself. Because the interface is open-ended, the user becomes a programmer, not of code, but of human intent.